Hi there. Good morning, afternoon, or evening to everybody who's joining us. My name is Adrian Ludwin, and I'm an engineer working on Google GCP Kubernetes Engine at Google. And today I'm going to be talking about how to build multi-tenant clusters using hierarchical namespaces. So there's at a brief overview, there's a couple things we'll be covering today. The concept of hierarchical namespaces is quite new, so I'll spend a little bit of time explaining both what multi-tenancy is, how hierarchical namespaces can be used to provide a multi-tenant cluster, and also if you're interested in contributing to the project, because it is all, of course, a part of the open source ecosystem, how you can help us out. So here's the topics we're going to go through today. We'll talk about why you should be interested in multi-tenancy. We'll talk about the foundation of multi-tenancy in Kubernetes, which is namespaces, and how these are being extended to become hierarchical. Then we're going to talk about the product called the Hierarchical Namespace Controller, or HNC, which implements these hierarchical namespaces, and I will give a slideware demo, which is much easier than a live one on this recorded session. I'll talk a little bit about some advanced HNC topics, and then we can talk about how you can contribute, how you can get involved, how you can get HNC and try it out for yourself. So first, let's talk about why to use multi-tenancy. I'd imagine if you are listening to this session, you probably have some idea of why you want this anyway, but let's go over it because sometimes different people come to this topic for different reasons, and there are a wide variety of reasons that you might be interested. So most companies care about two things called mainly cost and velocity. And if this seems a little bit reductive, well, you can take an expansive view to both of these. Cost and velocity encompass all kinds of other concerns, such as if you have a bunch of teams that are tripping over each other's feet, that's going to impact both your cost and velocity. But it does, of course, include the sort of more basic concerns, such as how much you pay your cloud provider and how quickly you're able to develop new features. One of the problems that you can have is that if too many different teams are trying to do too much on their own, they end up impacting both of these. And so let's look at how this works with Kubernetes. Kubernetes works really well for out of the box for one or a small number of users. So you've got a user, the user uses either the command line interface, kubectl, which we all know and love, or the API or some kind of graphical user interface to talk to the control plane. The control plane then communicates in turn to the nodes via the kubelets, and everybody is pretty happy. This also scales up well to small teams, and usually when you start talking about terms like tenants, the kind of tenant that you have in mind is a team. Now, there are other definitions of tenancy as well. Sometimes you can think of an application as being a tenant. If you're a SaaS producer, you can think of your customers as being tenants, or sometimes if your customers have customers, maybe those can be tenants too. But for the purpose of this discussion, we're mainly going to be talking about the development teams that want to use your cluster. And so once again, Kubernetes works quite well for a relatively small number of people out of the box. Now, what happens if you have two tenants or two teams? Do you give each of them their own cluster? This is a very common pattern. But the problem is that it doesn't really scale all of that well. And again, it impacts both your cost and your velocity. So in terms of cost, each cluster usually has some kind of overhead. Either there's an explicit fee per cluster, and even if there isn't, you're paying for the resources of the control plane, you're paying for system components such as, let's say, Istio, your logging system and monitoring system. And that's just direct monetary or compute costs. Then there's the effort that it takes to manage all of this. Who's going to operate all of these? Who is going to decide when it's time to go from one version of Kubernetes to another? And so what we find is that, well, this is a great way to get started, and it's a very easy way to get started. At some point, a lot of large companies or even medium-sized companies will quickly decide, you know what, we already have enough trouble managing the clusters we need to have in different regions. Why do we also have each team trying to manage it themselves? And so to solve these kinds of problems, part of the open source ecosystem includes the multi-tenancy working group. And it was formed to categorize and understand and then solve these kinds of multi-tenancy problems in the ecosystem. And so there's another SIG called the multi-cluster SIG, which is trying to solve the problem of having lots of clusters, but we are trying to solve the problem of reducing the number of clusters that you need to have. There's a couple of projects that's run by this group. One of them is HNC, which I'll be discussing in this presentation. Other ones include virtual clusters and a benchmark or a compliance project. I'll talk a little bit more about the working group at the end of this presentation, but if you are looking through these slides on your own, there's a link that you can click, or you can just search for us. We're easy to find. So the canonical view that we like to promote in the working group looks like this, where you have multiple tenants. They all talk to the same control plane, and their workloads run in different namespaces. And namespaces are the primary unit of isolation in Kubernetes. But what I found kind of funny is that you don't actually hear people talking about them very much. So let's talk a little bit about namespaces, because then we can see why it's important that we can make them hierarchical now. So namespaces seem boring. We don't actually talk about them a lot. They're a little bit like the walls in your apartment. They are not in and of themselves very complicated, but they make a lot of other things possible. The most obvious thing that comes to mind when you think of a namespace is just that it allows you to organize your objects. So for example, in namespace A and B, I can have objects that otherwise have the same name, which would conflict, but they're differentiated by the namespace name. That's great. You could probably do that by hand if you really wanted to. But namespaces actually do a lot more than that, especially when it comes to the area of multi-team tenancy. So there are some security features of Kubernetes pardon me, that require namespaces. So for example, let's talk about Kubernetes service accounts. Every workload runs as a service account, and secrets. Every workload can access secrets, and they are freely usable within a namespace. What that means is that anybody who has permission to deploy a pod into a namespace can use any secret or can run as any service account within that namespace, unless you set up other rules outside of the rules of Kubernetes. And so what that means is that even though in theory you can use different service accounts within a namespace to provide different levels of privileges to applications, that's not really a good solution for multi-team tenancy, where you don't want the humans to have access to those privileges, to be able to run pods as using elevated privileges. Now, I should note before I go on any further that the namespaces constructs only isolate the control plane, not the data plane. So if you put two pods into two different namespaces, they can land on the same node. And because containers are not a security boundary, something that escapes, if you have a malicious workload that can escape its container, it can attack other workloads running on the same node, or even the rest of the cluster. There are a lot of good presentations, especially from KubeCon San Diego 2019, that talk about this. So namespaces are great for the control plane. They are not sufficient to protect your data plane. You need to look into sandboxing technologies such as gvisor or Kata containers to defend the data plane, but those are out of the scope of this presentation. Moving on, there are many other features which work best with namespaces, even though technically you don't always need them. So for example, RBAC works really well at the namespace level. It is the only way that I'm aware of to scope the privilege of creating new objects, unless you want to go to the entire cluster level, I should say. And even if you want to look at other privileges, such as reading objects or updating or deleting objects, in theory, you can use RBAC at the per object level. But this is quite brittle, doesn't scale very well. So really, you want RBAC to apply at the namespace level in the vast majority of situations. This applies to many other things as well. Resource quotas and limit ranges aren't really about security. They're more about resource sharing. But again, they work best at the namespace level, or I think only apply at the namespace level. Network policies, similarly, they can be finely targeted using labels, but they work best using the namespace boundaries by default. Now, one caveat is that of network policies is that if you are looking at traffic coming from another namespace, the way to select that namespace is to use labels. And labels are a problem because they're not actually secure. Anybody who can edit any namespace can modify any label that is on that namespace. And what that means is that if labels are part of your security policy, there is no differentiation between any user on your cluster who is able to edit any namespace. So we're actually going to come back to that in a few moments, because HNC and hierarchical namespaces provide a solution to that problem. Now, that talks about why you should scope things to namespaces, but what happens if you want policies that are across different namespaces? Usually you're going to need some kind of tool and a source of truth that is outside of Kubernetes. So you can use CI GitOps tools like Flux or Argo. If you are in GKE, you can use tools such as Configsync or Anthos Config Management. All of these look at what's in a repo, typically in Git, and can propagate things to the cluster and typically across multiple namespaces. There are other solutions that are fully in cluster that add some kind of concept of accounts or tenancy. One of them is called Kiosk, which I haven't actually played with myself, but I want to look into it. Another one is called the Tenant CRD, which is actually also run by the Multi-Tenancy Working Group. But what we felt when we were starting HNC is that there was a need for a solution that was both fully Kubernetes native, so no dependencies on Git, and that didn't introduce a new concept, because both Kiosk or the Tenant CRD, they have a fairly well-defined idea of what a tenant should be. But as I mentioned at the beginning of this presentation, there's a great many different types of tenants. And so having something that's at one level lower than that can be really useful. This brings us to hierarchical namespaces. Hierarchical namespaces are namespaces. They are Kubernetes namespaces, but they've added this concept of ownership, which you can see here by the arrows. And what this ownership provides is the ability to delegate certain operations and the ability to impose policies that were on a parent namespace into a child or a descendant. And hierarchical namespaces are an add-on. They are provided by the hierarchical namespace controller, which I'll talk about in a moment. But let's talk about how they work. As I said, they express ownership, but on top of that, what they do is you can create subnamespaces without cluster level privileges. Namespaces are great, but if you want to allow a team to create a namespace that's limited by, for example, the policies of its parent, there's no way to do that. HNC provides a way for you to create a small object in a parent namespace, which results in the child namespace being created for you. It can allow you to cascade policies and secrets from one namespace to another so that you can limit these things to a subtree of namespaces without having to manually figure out where they go. It adds a set of trusted labels that you can use for policy application, and it's also easy to extend. So just to make some of these ideas more concrete, let's look at a demo of what HNC looks like in practice. So first I'm going to enable it on my cluster. Because I'm on GKE, I'm going to use a feature called Hierarchy Controller, which is part of Configsync. So I'm going to edit the operator manifest, and I'm just going to set Hierarchy Controller is enabled. And Hierarchy Controller includes HNC. If you're on OSS, no worries. It's just a one-line kubectl apply. You can find that from our GitHub repo. So now HNC is installed. You wait a few moments, and let's create a couple of regular namespaces. And I'll come back to what normal means in a moment. We'll have a more precise definition for that. So we've created these namespaces called parent and child. And if we get the list of namespaces, you can see they've shown up, but there's nothing special about them. They are completely normal top-level namespaces. And what I'm going to do now is I'm going to look at a plugin, a hierarchical namespace, HNS plugin, which is a kubectl plugin, which is part of the project. And I'm going to use the tree command and -a to see all namespaces to see what is the hierarchical structure of this cluster. And there is none. You get exactly the same output as what we had before because we have not set up any hierarchical relationships. So let's talk about hierarchical relationships. Let's use that plugin, the HNS plugin, to set a property on normal child. We're going to set its parent to normal parent. And if we go again and run that command, we can now see that normal child shows up as a child of normal parent. Now, as I said, what is this normal business that I've been talking about? Well, what we're going to see is that because we created these namespaces in the normal way, you can arrange them into hierarchies. We call these in HNC, we call these full namespaces. The opposite of full namespace is a subnamespace, which has a lot more limitations, but don't require cluster level privileges to create. And I'll be demonstrating those in a minute. So now that you have these hierarchical namespaces, what can you do with them? Well, let's create an RBAC role. So we're going to create an RBAC role called parent SRE, and we are going to put it into the parent namespace. So that's created now. Typically, if you looked in any other namespace now for this object, it would not appear, but we are going to look in the normal child namespace for this object, not normal parent. And what we can see is that it shows up. And not only does it show up as being inherited from the normal parent, because of course HNC is not actually magic. for an object to look like it appears in another namespace, we've had to copy it. And when we copy it, we set up this label, and this label is used by HNC to do things such as update this copy when the parent is updated, or just as importantly, delete it if the original object is deleted. I should add that by default, HNC does propagate only RBAC objects, so roles and roles bindings, but it's easy to configure to propagate any other type of object you like, although I wouldn't recommend propagating pods or the like. That's for things like network policies, resource quotas, limit ranges, and so on. So now let's talk about the opposite of a full namespace, which is a subnamespace. So here we're going to use that plugin again, but instead of creating a namespace, we say HNS create, and we're going to create a subnamespace child. And so this creates something called a subnamespace anchor. It is a namespaced object in the parent namespace. And if we look at the tree of the parent namespace, we now see that it has two children. One is the normal one, and one is the subnamespace. Now, what's a little bit hard to appreciate maybe from just looking at the slide is that you didn't need any cluster level privileges to create this. You only needed the ability to create a subnamespace anchor in the parent namespace. And so you could give people privileges to create this in some namespaces, but not in others. But once that namespace has been created, it is a full Kubernetes namespace, but you can't manipulate it directly. You can't delete it directly. To do that, you have to delete the anchor. You can't move it because it has been created by somebody who only had privileges within this one namespace, and so it cannot have its parents changed. There are a couple of workarounds around that, but those are beyond the scope of this presentation. So now let's talk a little bit about how you can extend HNC. So let's take a closer look at this namespace that we've created. I'm going to look at the subnamespace, but this part's the same for full namespaces as well. If you look at the namespace itself, you will see that there are a couple of labels that have a bit of an odd structure. They start with the name of another namespace, and then they have this kind of tree suffix. And what this does is this encodes the hierarchy. So what we're seeing here is that subchild, the namespace we're looking at, has a depth of 0 to itself and a distance of 1 to its parent. What this allows you to do is it allows you to select entire subtrees of namespaces. So for example, in your network policy, if you wanted to allow traffic in or out of any namespace owned by the same team, where team has a parent namespace, you can create that selector. Now, I said before, labels are not safe for security policies because anybody who has access to edit the namespace can modify them. What HNC does is it prevents you from doing that. If you try to modify one of these labels, it will be rejected, and if you somehow bypass the webhook, the reconciler will get rid of it. So you can trust these labels because HNC enforces them. Any other labels are fine. You can modify any label that doesn't begin with hnc.xcates.io, or sorry, have that in the suffix, but these labels are protected. So let's talk a little bit more about how you can extend HNC now. So what I'm going to do is I'm going to give a demonstration that shows a couple of extensions into other systems. And what I'm going to use here is Configsync, which is a Flux-like GitOps tool that is part of GKE. And what you can do is it already has a concept of namespace inheritance that's quite similar to HNC. In fact, HNC was inspired by it in part. But that hierarchy works in a very different way. Instead of being present on the cluster, what Configsync, which is the same as Anthos config management, what Configsync does is it allows you to define a tree of directories in Git, and you can create a bunch of YAML files in them, and these leaf directories, in this case Team A, Team B, and Team C, these become namespaces on the cluster. And so what we've just done now is I flipped over to another cluster where this is running. And if I look at the list of namespaces, you will see that Team A, B, and C have been created. I haven't shown it here, but if I looked for Acme, Org, or Eng, those are not synced. They do not appear as real namespaces on the cluster. But if you go look at Team B, which is from HNC's point of view is a root namespace, you can see that these labels actually have shown up. Now, how is this possible given that I said that these labels are trusted? Well, HNC defines an extension point called managed by that you can use to extend the hierarchy in ways that HNC doesn't natively understand. So in this case, we have told HNC that there is this other system called configmanagement.gke that is managing this root namespace. And we have told it what its additional hierarchical information is. In this case, you can see Acme Org and Team B, which is the namespace itself. And there are a bunch of things in place that stop you from adding this managed by annotation unless in ways that can damage security. And so what that means is that these labels are usable by any other system, such as network policies, that the regular HNC labels can use as well. You can also create a subnamespace underneath them. So here we're using HNC to create a service that's owned by Team B called Service 1. And now let's look at another extension point. Let's run a small application inside of that new service namespace. So we're going to run that, and it creates a service in a pod. And if we look at the pod, what we'll see is another extension that we've built. Again, this one only works in GKE for reasons that we'll see in a second. We can see all of those labels have been copied down to the pod. The reason we've done this is that logging in GCP is based on labels that are put on top of pods. And so what this does is this allows us to go into our logging system, in our case it's Stackdriver logging, and filter and route and analyze these logs based on the hierarchical structure. And other logging systems will have similar abilities, but they might integrate in slightly different ways. Again, what this is showing is how easy HNC is to extend by your platform team in order to solve your own problems. So let's have a look at one of these labels. So we're going to look at, for example, every log that came out of the engineering organization on this cluster. So in gcloud, in GCP, the way to do this is you create a filter, which is pretty straightforward. We're going to say that the Kubernetes labels must include this label, endtree HNC. You can see the name got mangled a bit, but with the depth having any value. And if we run that, we can see that we are reading the logs that came from that deployment of Nginx that we put into that pod. So again, the details here don't matter very much because it's going to be different in every system. It's going to be different on other cloud providers, on bare metal, on-prem. Whatever your logging solution is, your monitoring solution, is if it understands the concepts of Kubernetes namespaces or Kubernetes labels, you can use it with HNC because that's how HNC has been designed to extend. I'm going to very briefly cover some of the advanced topics with HNC, not in any depth, just so that you're aware that they exist and to give you an idea of the kinds of things that you have to think about when you're building a system like this. There are authorization checks in place to make sure that you cannot modify the hierarchy in bad ways, because if you move your namespace to a new parent, you get access to all of its secrets. This is obviously a dangerous operation and shouldn't be allowed unless you have access to those secrets already. We can do cascading deletion of subnamespaces. And so if you delete a parent namespace, all the anchors in that namespace get deleted, which deletes the subnamespaces and so on. Obviously, this is dangerous. And so there are a variety of methods that we have in place to make sure you don't do this on purpose. By accident. You can monitor HNC itself via OpenCensus, plus the objects that it creates in each namespace, and at the cluster level have a status section that you can use to ensure that everything's working the way you'd expect. And finally, we've put a bunch of thought into how you uninstall this. You wouldn't want all of your subnamespaces and all of the objects in them to disappear if you delete HNC. And so we've put effort into making sure that you'll get a pleasant experience if you try it out and it doesn't work for you. In terms of how you should actually use this, for simple organizations or in dev clusters, it's pretty easy to understand how you can use this. You can give teams control over their own namespace hierarchy without letting them, which includes letting them create their own namespaces, without giving them the ability to modify or impact anybody else. And again, you can do this without HNC if teams do not have to own multiple namespaces. As soon as they do own multiple namespaces, it becomes a lot more complicated. In a more complex production environment, it allows you to do things like safely distribute secrets among related namespaces. It allows each team to have their own continuous delivery tooling, such as GitOps, but then you can give the service accounts for those tools limited privileges and not to the entire cluster, which has been required in the past. In summary, what you can do is you can extend HNC to create these higher level tools, including concepts such as accounts or tenants that are today provided by projects such as Kiosk. Finally, let's wrap this up. How do you get this? How do you play with this? Well, the most obvious way, if you're on open source, is to just go to our GitHub's releases page. So it's pretty easy. You can search for Hierarchical Namespace Controller, or if you are looking at these slides, you can click on that link to go to GitHub. Follow through to the releases, and you will find the latest version of HNC. And it's a one-line install to get it onto your, or a two-line install to get it onto your cluster, another couple of lines to download that plugin. If you are on GKE or Anthos, you can enable Hierarchy Controller, as I showed, using in Configsync or Anthos Config Management, which gives you a couple of these extra integrations, like the integration with logging. And I would expect in the future that other providers would provide similar integrations into their cloud. And then there are user guides and demos that can help you get started. We are interested in contributors. There's a bit of a laundry list of features that we are considering adding to HNC, such as exceptions. We're looking at a way to implement namespace CRDs, which sounds like a contradiction in terms, but contact me later if you want to talk about that, and improve productionization, such as Prometheus support. And of course, we are always happy for people to test and help document the product. Finally, if you're interested in multi-tenancy as a concept, please come and join the multi-tenancy working group. We have a variety of projects that we are leading, not just hierarchical namespaces. This includes virtual clusters, the tenant CRD, and benchmarking. And this effort is led by Tasha Drew at VMware and Sanjeev Rampal at Cisco. It's a really friendly community. We meet every 2 weeks on Tuesdays, and please come to our Git repo where you can find all of the information to join the mailing list and to join our bi-weekly Zoom calls. That's the end of this pre-recorded session, and I will see you from my point of view in about 3 weeks to answer your questions, or we can go to questions right now. Thank you very much. Hi there. It is now Wednesday, August the 19th. I've been standing here for 3 weeks in the same shirt, and I'm ready to answer some questions now. So the first question comes from a guy with a really good name, Adriano Pizzuto, asks, it looks like there's a competing project in the same SIG called the Tenant CRD. I just mentioned that actually on one of the last slides. It is not a competing project. It is a more opinionated solution. It's at a higher level of the stack. What I would hope at some point in the future is that it might actually be rebased onto hierarchical namespaces, but it's got a very different purpose. Basically, if you look at that user model and it works perfectly for you, that's great. I don't think it's got as much activity on it. It is actually working much more closely with the virtual cluster project, which is much more about hard multi-tenancy than HNC, which is much more about sort of shared or soft multi-tenancy. And by the way, if I don't answer your question today, please feel free to contact me through the multi-tenancy working group. My email is there. You can see me on Slack, and there are lots of places to reach me. And by the way, I'm sorry for anyone who was looking for the slides who can't see them on Shed. If you look for my name, Adrian Ludwin, on Speaker Deck, I have uploaded them there as well. I'm hoping they'll pop up on Shed, but they haven't been turning up yet. Daniel asks, can you scope scoped things to HNS like CRDs, for example? As I said, no is the short answer. The namespace controller is all about namespaces. However, we have been chatting about some possibilities to, let's say, simulate namespace CRDs in Kubernetes. And if we can do that, then HNC will work well with them. As for getting true namespace CRDs into Kubernetes, that is a very big task, and unlike HNC, which is just an add-on, true namespace CRDs would require changes to Kubernetes and some pretty expensive ones as well. But please do join us on the mailing list or on Slack and explain what your use case is for stuff like this, because the more use cases we have motivating this, the higher the chance that somebody will be able to do anything about it. Andrew asks, any thoughts on the approach that was shown during a hard multi-tenancy solution? I think I may have watched that one. If that was the one about running lots of different API servers on one cluster, that is a great solution if you need that kind of hard multi-tenancy. Virtual clusters, which are being run through the multi-tenancy working group, are another solution if you need shared nodes as well as multiple API servers. I apologize if I'm responding with the wrong one, but basically HNC is not really for the harder use cases. It really is for the more kind of cooperative use cases, which is not to say you cannot you cannot put in policies that add for your safety. That's the whole point. But it's not really for like mutually hostile tenants, at least not at this point. It would take probably several years of hardening before we could get there. Is hierarchical resource quota management part of the HNC roadmap? It is something that is asked for quite frequently. However, we have some other, let's say, more pressing concerns. This is, as I mentioned in that second to last slide. Let's see if I can... there we go. Hierarchical resource quota, second from the bottom there. Yes, that is a feature that we would be happy to accept some contributions from. It's certainly something that's come up in discussion. And yeah, if you are interested in contributing, we are happy to hear it. As far as the roadmap goes, it is on, I would say at the moment it's on our nice to have list, but we have some more important features that we need to get in there before. Can I eval HNC in GKE at the moment, or do I need to set up HNC on my own in GKE? So if you are using GKE, as I showed in the demo, you can use a feature called Hierarchy Controller, which is part of a larger feature called Configsync. So if you just go to the Google Docs, you'll be able to, the Google Cloud documentation, search for Hierarchy Controller. That is a curated version of HNC with a couple of GCP-specific extensions. Other than that, you can certainly install it based off of our releases on GitHub, which we've tried to make that as easy as possible as well, because that's what we do during our development process every day. Does the child namespace and subnamespace get owner ref of the parent namespace? I wish it did. We had to set a lot of that stuff up ourselves because owner refs only work within a namespace, because as I mentioned, namespace is the default boundary for a lot of stuff in Kubernetes. And so since we could not have references across namespaces, there was no good way to use owner ref to make this work. If you go to our repo and check out the original design doc, I think we cover, like we looked into that and we explained why that wasn't possible, unfortunately. Kate's native resources, sorry, this is Max asking, Kate's native resources are dealing with HNC. How about OPA or Linkerd? I must confess, I have not looked at Linkerd at all, and that includes in relation to HNC. Now, OPA I know relatively well, especially in its form as gatekeeper, and those labels that I showed, the tree labels, that is an extension point that we could write some policies in Rego based off of, and actually that's on my list of things that I want to try out in the next month or two. I talk with a bunch of the gatekeeper folks pretty frequently. And so, yeah, I do want to try that out, but that is how you would integrate Gatekeeper and OPA with HNC, is that you would go based off of the labels on the namespaces. If we need more than that, so for example, if we wanted, let's say, a constraint template in Gatekeeper, which is to say a policy that applied only to a subtree of namespaces, we need to do a bit more work there because right now everything in Gatekeeper is cluster level. So first we would have to get namespace level constraints into Gatekeeper, not an impossible task, but not a completely trivial one either. And then they would naturally propagate along with, you could set HNC up to propagate them very easily. Can you mark other labels as protected or unmodifiable? No, you can't. The idea of having what's called ACLed labels or ACL, so access control list on labels, is a tricky problem to solve in general, but it would be, yeah, if you have a use case for that, please give me a shout. We could do something at the code level, but it would be a one-off solution. Is there any reference for setting up with GitOps tools like Flux or Argo? So at the moment, no, there isn't. I haven't tried it with anything. I haven't even tried it with Configsync, to be honest. But HNC objects are simply like any other Kubernetes objects, and so you can simply check them into your repo. At some point, it would be actually that would be a great place to make a contribution if you wanted to try that out. Write a Medium post or a blog post or or contribute to our own documentation. That would be great. We would welcome that. How do you manage cluster capacity and namespace quotas? I think I covered this already. Hierarchical namespace quotas are something that we would be interested in adding if we had any contributors. Let's see. We're running a little bit low on QA. I'll get through as many as I can, but again, please do contact us on Slack or on the multi-tenancy mailing list. Oh, and I'm sorry, we are at time, so I apologize to James, Bartha, and Lassie, and Max, who I was not able to get to your questions, but please do contact us on Slack or on the mailing list, and I'll answer you there. So thank you very much for joining us, and I'll see you later.